Hello students, so today's video is on unit 9 amines. Before solving this multiple choice questions, you study all the concepts which come under NCERT textbook regarding amines. What are amines, how they are prepared, their physical properties, their chemical properties, important compounds formed from amine. So resulting, that is benzene diazonium halides. So from benzene diazonium halide, what are the reactions and all. So you please study those once and then try to solve the questions onto it. So we'll go with the question number 1. Which of the following is a tertiary amine? So here if you look at the given options, the given option 1 is methyl cyclohexylamine, second is triethylamine, third is tertiary butylamine, and fourth is N-methylaniline. So we'll draw the structures of this to understand which is a tertiary amine. So let you know the difference that if one of the hydrogen atom of ammonia is substituted by an alkyl or aryl group, it's a primary amine. If two hydrogen atoms are substituted of ammonia are substituted by an alkyl or aryl group, it's a secondary amine. And if all the three hydrogen atoms are substituted by an alkyl or aryl group, then we say it is a tertiary amine. So we'll draw the structures of this and then we'll consider which is a tertiary amine. So here if we consider the structure, so this is the structure of 1-methyl cyclohexylamine. So in 1-methyl cyclohexylamine, you can consider that only one of the hydrogen of ammonia is substituted by this group. So it is nothing but it's a primary amine. Similarly, we'll go with option B. Option B was triethylamine. So in triethylamine, here we see that all the three hydrogen atoms are substituted by an alkyl group, that is ethyl group, and since all the three hydrogen atoms of ammonia are substituted by an alkyl group, it becomes a tertiary amine, and our correct option for this would be option B. We'll check with remaining two also. So option C was tertiary butylamine. So when we draw the structure of tertiary butylamine, so this is a structure where only one of the nitrogen of ammonia is substituted by an tertiary butyl group. Hence it is also an example of primary amine. So this is a primary amine, and option D was N-methylaniline. So here if you see, one hydrogen is substituted by benzene ring, another by methyl group, and two hydrogens are substituted. So it's an example for secondary amine. So the correct answer for the question number 1 is option B, tertiary amine. So here the correct answer is option B, that is triethylamine. Sorry, I said tertiary amine, it is triethylamine. Next we'll go with the correct IUPAC name for CH2 double bond CH, CH2 NH CH3. I'll write the structure here properly. So when I write the structure properly, it is like this: CH2 double bond CH, CH bonded to CH2, this CH2 bonded to N, N bonded to H, and to that N only what is bonded here, CH3. So higher alkyl group becomes parent chain, lower alkyl group becomes substituent. Substituent is on nitrogen atom, hence we can write its prefix as N-methyl. Methyl is bonded to nitrogen atom, so N-methyl. Then it is having 1, 2, 3 carbon atoms, so prop. And here if you see the carbon atom, when you select the longest carbon chain, that is if you give first preference to functional group, this is first position, this is second, and this is third. Your double bond is on second carbon atom, so prop to N, and on first you have amine group, so 1 amine. So the correct IUPAC name here is N-methyl prop to N1 amine, and hence the correct option here would be option D, N-methyl prop to N1 amine. We'll go with the next question. Among the following, the strongest base in aqueous medium is? So in aqueous medium, you should know that we have already studied in NCERT book that the basicity of amines in gaseous phase as well as in that of aqueous medium. In aqueous medium, always secondary amines are more basic. So here if you see, this is primary amine because only one hydrogen of ammonia is substituted by alkyl group. This is also a primary amine, but here if you see two hydrogens are substituted, it's a secondary amine, and this would be more basic. Hence the correct answer for question number 3 is option C. Next we'll go with question number 4. Amines are obtained from, yes, amines can be formed from amides by reduction reaction or by Hofmann bromamide degradation reaction. even from nitro compounds by hydrogenation reaction, even from alkyl halides by carrying out ammonolysis reaction. So amines are obtained from all the three reactions. Hence the correct answer is option D, all. Next, if we go with question number 5. So question number 5 is acid amides can be converted into primary amines using. So here they have given Claisen reaction, Perkin reaction, Hoffman's reaction and Rosenman reaction. Remember, acid amides getting converted to primary amine is always by Hoffman bromamide degradation reaction. Hence the correct option for question number 5 is option B, Hoffman's reaction. Next we'll go with question number 6. So question number 6 is the best reagent for converting 2-phenyl propanamide into 2-phenyl propanamine. So without changing the number of carbon atom when you are converting, the medium what we use here is lithium aluminium hydride in ether. Hence the correct answer is option D. This is one of the method of preparation of amine. Next, if we go with question number 7. So question number 7 is Hoffman bromamide degradation reaction is shown by. So you should know that it is shown only by amides. So here in this options given are, first is aromatic amine. No, we need a amide here. Next is aromatic amide. Yes, it can be the correct answer. Next is aromatic nitro compound. No. And lastly, it is an amine, again aromatic amine, so it is also not a correct answer. So correct answer is an amide. Amides only undergo Hoffman bromamide degradation reaction. Amide means they should contain CONH2 group. So the correct answer is option B. Next, question number 8. The best reagent for converting 2-phenyl propanamide into 1-phenyl ethanamine. So if you look here, amide has 3 carbon atom. In ethanamine, 1 carbon atom is decreased and amide is getting converted to amine. And this is a reaction shown by Hoffman bromamide degradation reaction. And in Hoffman bromamide degradation reaction, we take bromine and NaOH. So here the correct answer is option B. We'll try to write the reaction and see what would be the possible reaction here. So here when we consider the reaction 2-phenyl propanamide, when it's made to react with a mixture of bromine and NaOH, amide group P is lost. It gets converted to 1-phenyl ethanamine and the byproducts obtained here will be Na2CO3 plus of 2NaBr plus of 2H2O, and this itself we call it as Hoffman bromamide reaction. So the correct answer for the question would be option B, NaOH bar Br2. Next we'll go with question number 9. Preparation of amines by ammonolysis of alkyl halide. It is an example of, so it is nothing but it's an example of nucleophilic substitution reaction. So correct answer is option B, nucleophilic substitution reaction. Next we'll go with question number 10. Benzyl amine may be alkylated as shown in the following reaction. So this is how we can carry out the reaction of benzyl amine. Which of the following alkyl halide is best suited for this reaction through SN1 mechanism? So we know the order of SN1 mechanism already discussed in haloalkane, haloarane. Tertiary alkyl halides are more reactive than secondary than primary. So here if you look, there is no tertiary alkyl halide, and since benzyl group is present, remember that benzyl halides can undergo, or benzylic halides can undergo SN1 reaction easily. And hence the correct answer for this question is option C, benzylic halide, that is benzyl chloride. Next we'll go with question number 11. So question number 11 is, which of the following reagents would not be a good choice for reducing a nitro compound to an amine? So nitro compound to an amine can be reduced by H2 in the presence of catalyst, iron and HCl as well as tin and HCl, but not by lithium aluminium hydride, as they do not easily form amine. First they form imine and then amine, and it is also an expensive reagent, so which is not a good choice. It is lithium aluminium hydride, option B. Next we'll go with question number 12. Which of the following should be most volatile? So here if you see, the amine given are propanamine, which is a primary amine. Then second one is you are having tertiary amine, that is trimethylamine, and then here you are having ethyl methylamine, which is a secondary amine, and you are having propane. Now here if you consider, it has NH bond, so it will form hydrogen bonding, so it is less volatile. Here also it has NH bond, it will form hydrogen bonding, so it is also less volatile. These two do not form hydrogen bonding, so they both are most volatile, and among these two, alkenes are most volatile. Hence Roman number 4, that is propane, is most volatile, and Roman number 4 is given as option B. So propane is most volatile among the following. Next we'll go with question number 13. So question number 13 is, compound formed when benzamide is warmed with bromine and alkali. So when it is warmed with bromine and alkali, what it will form? Benzamide, bromine and alkali, amide gets converted to amine. So formula of benzamide is C double bond O NH2. So when you take a mixture of bromine and alkali, remember it is Hoffman bromamide. Whenever it is Hoffman bromamide, carbonyl group is removed and you get the resulting product as a primary amine, and here you get it as aniline. Hence the correct answer is option D, aniline. Next we'll go with question number 14. The source of nitrogen in Gabriel synthesis in amines. So it is nothing but potassium thalamide, which is the source of nitrogen. So the correct answer is potassium thalamide. Here they have mentioned Gabriel synthesis, but you should know that in NCERT the name given is Gabriel thalamide synthesis. So thalamide itself is the source of nitrogen. Hence the correct answer is option D, potassium thalamide. Next we'll go with question number 15. So question number 15 says that Gabriel thalamide reaction used. So Gabriel thalamide reaction is used in the preparation of primary amine. Hence the correct answer for question number 15 is option A, primary amine. Next we'll go with question number 16. So question number 16. IUPAC name of CH3 twice CHNH2 is. So more properly if we write the structure, it would be CH3C, CH3, CHNH2. According to the IUPAC rules, this is your functional group. It should get the lowest position. So when we number the carbon chain in any of the direction, you get only 3 carbon atom, 1, 2, 3. Other way also you would get 1, 2, 3. A functional group is on second carbon atom. There is no substituent attached, so no prefix. Now directly we'll go with the word root. So 3 carbon atom, hence the word root is prop, singly bonded. So AN, your functional group is on second carbon atom, so 2 amine. So either you can write the IUPAC name as propan 2 amine or 2 propanamine. Hence the correct answer is option B, propan 2 amine. Next we'll go with question number 17. The hybridized state of nitrogen in methylamine is. So methylamine, if we write the structure, CH3 nitrogen bonded to 2 hydrogen and 1 lone pair of electron. When the sum of your lone pair and bond pairs is equal to 4, you remember that it is sp3 hybridization. If the sum of your bond pairs and lone pair is equal to 3, remember it would be sp2, and if it is 2, the hybridization is sp. So here the correct answer would be sp3 hybridization, because 3 bond pair, 1 lone pair, and hence the correct answer is option B, sp3 hybridization. Next question number 18. A secondary amine is a compound with 2 NH2 groups? No. A compound with 2 carbon atoms and an NH2 group? No. A compound with the NH2 group on the carbon atom in number 2 position? No. A compound with 2 hydrogen atoms of NH3 been replaced by organic group? Yes. So correct answer is option D. Next we'll go with question number 19. Aliphatic amines are soluble in water because. So aliphatic amines, they contain NH bond, and if they have NH bond, they form hydrogen bonding with water, and hence the correct answer is option A, because of formation of hydrogen bonds with water. Next we'll go with question number 20. Question number 20 says that the basic character of amines is due to. Options given are high electronegativity of oxygen, presence of nitrogen atom, lone pair of electrons on nitrogen atom. Remember, any amine bonded to nitrogen will have a nitrogen having lone pair, and when nitrogen has a lone pair, it has the ability to donate that lone pair, and when it donates the lone pair, we call it as Lewis base. So this indicates its basic character. So the basic character of amines is due to the lone pair of electrons on nitrogen atom, and hence the correct answer is option C. Lone pair of electrons on nitrogen atom. Next we'll go with question number 21. A solution of methylamine. Remember that methylamine is basic in nature. This is a basic thing, you have studied it in your 10th standard, that acid changes blue litmus to red and a base changes red litmus to blue. So here methylamine turns blue litmus to red. No. Why? Because it is basic. If you dip blue litmus, it will remain blue only. Next, turns red litmus into blue. Yes. Why? Because it is basic in nature. So the correct answer is option B. Next, we'll go with question number 22. Methylamine is stronger base than ammonia. This is due to the reason that. So why methylamine is a stronger base than ammonia? Because of the electron releasing group of methyl, and hence the correct answer is option A. Methylamine is electron releasing in nature. Next, 23. Aniline is dash than methylamine. Aniline is less basic than methylamine. Now, why aniline is less basic than methylamine? In aniline, when you consider the lone pair of electron present on nitrogen atom, it is involved in conjugation with the benzene ring, which we call it as resonance. And if it is involved in conjugation, it is less available for donation. But in case of methylamine, what happens? Due to the electron releasing nature of methyl group, the lone pair of electron is easily available for donation. Hence the correct answer is aniline is less basic than methylamine. That is, greater the ease of donation of an lone pair of electron of nitrogen, greater is its basicity. So methylamine is more basic, aniline is less basic. Next we'll go with question number 24. Among the following compounds, ammonia, methylamine, aniline, ethylamine, the least basic compound is. So when we consider question number 24, the least basic compound would be aniline. Why? Because the lone pair of electron is not easily available for donation due to the presence of, due to the resonance or conjugation with benzene ring. Next we'll go with question number 25. So question number 25. Aminomethane reacts with excess alkyl halide to give. So this is nothing but this is ammonolysis reaction. And when ammonolysis of alkyl halide with excess reagent is carried out, it results in the formation of quaternary ammonium compound. Hence the correct answer is option D, quaternary ammonium compound. Next we'll go with question number 26. So question number 26 is the maximum number of molecules of methyl iodide that can react with a molecule of primary amine is. Maximum number of molecules of methyl iodide, that is CH3I alkyl halide, with the primary amine. So we have primary amine means RNH2 and a lone pair of electron. So both the hydrogen atoms can be replaced by an alkyl group and the lone pair would be donated and form a quaternary salt. So maximum number of molecules of methyl iodide required would be 3. So the correct answer is option C. So when we represent the reaction here, if this is your primary amine, if you carry out the reaction with the CH3I in one step, it will form RNCH3 and H. Reaction of this with another methyl iodide, it would form RNCH3 and CH3. And another reaction with CH3I, it results in the formation of RNCH3, CH3, CH3 plus and I minus, that is quaternary salt. So number of CH3I required here are 1, 2 and 3. So the correct answer is option C, 3. Next question number 27. Carbyl amine test is used for the detection of. So both aliphatic and aromatic primary amine can be detected using carbyl amine test, where you get a foul smell due to the formation of isocyanide. Hence carbyl amine test is also called as isocyanide test. We'll go with question number 28. Methylamine reacts with HNO2 to form. So when methylamine reacts with HNO2, it forms a diazonium salt which is highly unstable and it undergoes further reaction to form methanol, and hence the correct answer is option C, CH3OH. The gas evolved when methylamine reacts with nitrous acid. So when methylamine, I will represent the reaction here. When methylamine reacts with nitrous acid, it forms a CH3N2 plus X minus, which is highly unstable. It undergoes reaction even with small amount of moisture. It results in the formation of CH3OH, N2 plus HX. So the gas liberated is N2. The product formed is CH3OH. So here it was option C. Here it is option B. The gas evolved is nitrogen gas. Next we'll go with question number 30. So question number 30 is reduction of aromatic nitro compounds using Fe and HCl will result in the formation of, it is usually an amine. So nitro compounds are converted to amine by making use of tin and HCl, iron and HCl. And it is aromatic nitro compound means you will get an aromatic primary amine. Hence the correct answer is option C, aromatic primary amine. Next question number 31. Acetanilide is obtained by the reaction of aniline with acetyl chloride or acetic acid. Acetic anhydride. This reaction is called as, since you are introducing an acetyl group, it is called as acetylation reaction. So correct answer is option B. Next, methylamine on benzoylation gives. So methylamine is nothing but CH3NH2. Benzoylation means you are making use of benzoyl chloride, that is C double bond OCl. You are introducing a benzoyl group in the place of hydrogen. So the product formed would be CH3NH, and here C double bond O, which is bonded to benzene ring. So this is a product obtained, which we name it as N-methyl benzenamide, and hence the correct answer is option C, N-methyl benzenamide. And this reaction, since you are substituting an benzoyl group, we call it as benzoylation reaction. Next, question number 33. So in question number 33, aniline plus HNO2, that is NaNO2 plus HCl, that is diazotization reaction. We get the product as C6H5N2 plus Cl, we have used, so Cl minus, and this reaction is called as diazotization reaction. Hence the correct answer is option A. And you should remember this reaction is carried out at 273 to 278 Kelvin or 0 to 5 degree Celsius. Next we'll go with question number 34. The product formed by the addition of NaNO2 and dilute HCl to aniline at 0 degree Celsius is. So this is nothing but the above reaction what we have discussed. So the product formed is benzene diazonium chloride because HCl is used, and hence the correct answer is option C, benzene diazonium chloride. Next we'll go with question number 35. What is Hinsberg reagent? So you should know that Hinsberg reagent is nothing but benzene sulfonyl chloride, represented by the molecular formula C6H5SO2Cl, and here this is option D, benzene sulfonyl chloride. Next we'll go with question number 36. So question number 36 is N-ethyl benzene sulfonamide. So here if you write the structure of it, N-ethyl benzene sulfonamide. So to N you are having CH3, CH2, N group, it is ethyl group bonded, and then next you are having N-ethyl benzene sulfonamide. So N is soluble in alkali. So which hydrogen is present here? We say that it is an acidic hydrogen. Due to the presence of this acidic hydrogen, when you dissolve it in alkali, it easily reacts with it, and hence we say that it is soluble. So the correct answer is option A, hydrogen attached to nitrogen in sulfonamide is strongly acidic. Next we'll go with question number 37. The reaction ArN2 plus Cl minus, that is benzene diazonium chloride, in the presence of CuHCl forms chlorobenzene plus N2 plus CuCl, and it is named as Gutterman reaction. Instead of CuHCl, if they give you CuCl2 in the presence of HCl, it will give the same product, chlorobenzene and N2 gas, and that would be Sandmius reaction. But since they have mentioned only copper in presence of HCl, it is Gutterman reaction. Next, question number 38. So question number 38 is best method for preparing primary amines from alkyl halides without changing the number of carbon atoms in the chain is. The correct answer is option B. So here they have asked you primary amines from alkyl halide. So here Hoffman bromamide reaction, we use amide. This is not applicable. Sandmeier's reaction, we form aromatic halides. So this is also not a proper reaction. Gabriel thalamide synthesis, primary amines we prepare using alkyl halide. We use alkyl halide to get alkyl thalamide, and hence this is a proper reaction. Reaction with ammonia gives you a mixture of primary, secondary, tertiary and quaternary ammonium salt. Hence this is also not a proper method. So the correct answer for question number 38 is option B, Gabriel thalamide synthesis. Next we'll go with question number 39. So question number 39 is, during nitration of aniline, amino group is protected by. So amino group protection means just to get a para product, what we do is first we carry out acylation or acetylation, and hence here we say that the correct answer is option A, acetylation. Remaining option hydrolysis, saponification and sulfonation are not correct, they are wrong. Next we'll go with question number 40. So question number 40 is, which of the following methods of preparation of amine will give same number of carbon atoms in a chain of amine as in the reactant? So here the options given are reaction of nitrite with lithium aluminium hydride, reaction of amide with lithium aluminium hydride followed by treatment with water. So yes, reaction of amide with lithium aluminium hydride followed by treatment with water will give you the amines having same number of carbon atom in the chain of amines as in that of the reactant. So with this we complete the multiple choice questions of amine. So these are few questions which are maybe important for your board exams. Prepare well for the exams. All the best. Thank you for watching.